So section 4.2, constructing a second solution from a known solution. So we're going to be dealing with a second order differential equations, means has y double prime in it. They will give us one of the solutions, and we are going to use that solution to construct a second solution. Later on throughout the course, we will show you how to find the two solutions in less than a minute. So we always teach the hard way first, and then we move on and teach you the easy way. But for the meantime, it's just to kind of help you think even more outside the box. That's why we teach you the hard method. So this method, or the process we use to use one given solution to find the second solution, is called reduction of order. So we're gonna reduce the order from a second degree into the first degree. And how does that work? Let's say we suppose that y1 of x is a solution or a zero of the differential equation a2 of x y double prime plus a1x y prime plus a0x y equals to 0. And the question here, how do you find y sub 2 of x? And again, this can be found by reducing the order, which is the second degree order, into the first order equation or differential equation. And this will be done by a simple substitution. It will be done by a simple substitution. This can be done using, and it's going to be always all the examples we do, including the homework problems, using y equals u of x times y1 of x. Whatever y1 will be always given, that's the first solution, or the first zero. So by doing this, we are going from here always get y prime and then y double prime, then substitute into the given differential equation. Any questions about this? So you always use this assumption here, the same assumption, y equals u of x times y1 of x. y1 will be given. You find y prime using the product rule, and then from there find y double prime, and then substitute into the given differential equation. Then the new form will look easier than the given form. And to see this, how this works, let's say it's given that y equals x cubed is a solution to the differential equation x squared y double prime minus 6y equals 0. Use reduction of order to find the second solution. So again, as I said, that given y equals x cubed, that's y1 of x. That's the first solution. So we let y equals u of x times the given x cubed, y1 of x. And the process here is we need to find y prime and y double prime. We find y prime using the product rule, u prime of x times x cubed plus 3x squared u of x. That's y prime. Y double prime is u double prime of x, x cubed plus 3x squared u prime of x plus 6x u of x plus 3x squared u prime of x. And notice something, this and this are like terms, we can combine them, so keep this the same. You get 6 copies of x squared u prime of x plus 6x u of x. And from here, what we can do is substitute this back into the given differential equation. What do we get? We get x to the fifth u double prime of x, 6x to the third u of x, 6x to the fourth u prime of x, 6u of x times x cubed. Notice these cancel each other. We can divide by x to the fourth. We give x u double prime x 6u prime of x equals to 0. We now divide everything by x. We get u double prime plus 6 over x u prime equals 0. Now, what do we do now? We use another variable. Let w be u prime. This means w prime is u double prime. So then this last equation becomes w prime plus 6 over x w equals to 0. And now we need to solve this. We can use the integrating factor mu is e to the integral of 6 over x dx, e 6 natural log of absolute value of x, e natural log of x to the 6, which is x to the 6. That's the mu, the integrating factor. So now we have x to the 6, the integrating factor, times w prime equals 0. If we integrate both sides, we get x to the 6 w equals a constant, 0 plus a constant. But what is w? W is u prime. So now this can be written as du dx equals c. U separable, du is c dx over x to the 6. which can be written as x to the negative 6. Integrating both sides, we get u equals negative 1 over 5 c x to the negative 5 plus another constant, call it c1. This is u, or u of x. Now remember how we let y equals u of x times x cubed, right? We can substitute the u we just got in here. Negative 1/5 x to the negative 5c plus c1 x to the third. And if we multiply it out, we get negative 1 over 5 x to the negative 2c plus c1 x to the third. This can be rewritten as negative c over 5x squared plus c1x cubed. This one here, notice this one is y1 of x. This is known to us. So what we got here, this is all constant. What is left? It's 1 over that. This is our y2. So y2 of x is x to the negative 2. That's what we're looking for. You always drop the constants and worry about x. Just a function in x. No need for the constants. So if you take this y2 and differentiate it twice and substitute into the original differential equation, it should work. Another example, let's say we have y double prime minus y equals to 0. It is known that y1 of x equals e to the x as a solution to this differential equation. Find the second solution. So Aditya is asking, what about if you include the constant? Yes, it will still work out. It will just cancel out at the end. Assume you're done. So we're gonna go over it now. We let y equals ux times the given y1 of x. Y prime by the product rule, it's u prime of x ex plus u of x times the derivative of ex, which is ex. Y double prime would be u double prime x ex plus u prime x ex plus u prime x ex plus ux ex. The middle ones can be combined. U double prime of x ex plus 2u prime of x ex plus u of x ex. What's e to the negative x? The answer, right? So now we substitute these back in, and I got, when I substitute that, I got u double prime plus 2u prime equals to 0. We let u prime be w, and from here u double prime would be w prime. So that equation becomes w prime plus 2w equals to 0. Ready for integrating factor. E integral of 2 dx e to the 2x. Then you have e to the 2x times w equals to 0. Integrate both sides. You get e to the 2x times w is the constant. Then w is u prime. So you can rewrite it separated. Ce negative 2x dx. Then integrating both sides gives us u equals negative 1/2 ce negative 2x plus c1. That's u of x. And remember, y equals u of x times ex. Negative 1/2 ce negative 2x plus c1 times ex. Multiply that out, negative 1/2 ce negative 2x times ex negative x plus c1 ex. Again, this is y1 of x, the given one, and this would be y2 of x that we are looking for. This is the second solution to the given differential equation. Now we can look at the general case. What happened for the general case? Is there a shortcut or not? That's what we're going to do here. Show you. In general, if we have as a second order differential equation, y double prime plus p of x y prime plus q of x y equals to 0 with known solution. Known means given. y1 of x. We followed the same process as before, same procedure. We let y equals u of x, y1 of x. Then y prime equals u prime of x, y1 of x, plus u of x, y1 prime of x. Y double prime equals u double prime of x, y1 of x, plus u prime of x, y prime of x, plus u prime of x, y1 prime of x, plus u of x, y1 double prime of x. These two can be combined. U double prime of x, y1 of x, plus 2u prime of x, y1 prime of x, plus the last one stays the same. So I found the second derivative. Now I want you to try to substitute this into the original equation, this equation here. The y double prime plus p of x, y prime plus q of x, y equals 0. So try to substitute it in before I show you. With the substitution, let's see what we get. U double prime of x, y1 of x, plus u prime of x, y prime 1 of x, u prime of x, y1 prime of x, u of x, y double prime 1 of x, u prime of x, y1 of x, p of x, u of x, y1 prime of x, p of x, u of x, y1 of x, q of x equals to 0. Now we can collect the terms with u of x. That gives me y1 double prime, p of x, y1 prime, q of x, y1 of x, plus we collect those with u prime of x, 2y1 prime of x plus p of x times y1 of x plus u double prime of x, y1 of x equals to 0. Then notice something here. This part, that's the function, it's the given equation itself, which is given equal to 0. So this whole thing is equal to 0. It's gone. What is left is y prime of x, 2y1 prime of x, plus p of x, y1 of x, plus u double prime of x, y1 of x equals to 0. Now I'm gonna rewrite this as u double prime of x dividing everything by y1 of x, 2y prime of x plus p of x, y1 of x, like so. This looks like what we did earlier with the specific examples. We can follow the same procedure and let w be u prime, means w prime is u double prime, means double prime of x. Then this last equation turns to be w prime plus, we can split this into 2y prime 1 of x over y1 of x plus p of x, and u prime is just w equals to 0. Okay, so here we start with the integrating factor, e to all of this stuff, dx. And how are we going to handle this? We can split this over y1 of x dx plus the integral of p of x dx. So the first one is easy to integrate here. Take the 2 out. If you take the bottom one to be u, the top would be u prime du, which we have it. So it's natural log of absolute value of y1 of x plus, or you can multiply this, rewrite it as a multiplication, because if they have the same base, we add the exponents. This one becomes e natural log of y1 of x square times e the integral of p of x dx. That's y1 of x square times e the integral of p of x dx. So this is the integrating factor. Then we can rewrite this as w y1 of x square e the integral of p of x dx, because we don't know what the integral of e to the p of x dx, that derivative equals to 0. Then w y1 of x square e the integral of this equals a constant c. W is u prime. So we can do separable du dx, so du equals the integral, if you integrate both sides, y1 of x square e integral of p of x dx. And there is the c. Then u would equal to the integral c, move that thing up, the exponential part, dx over y1 of x square. Okay, y1 of x square. Plus, call it c1, because we integrated both sides. Now, since we know that y is u of x times y1 of x, we can substitute this integral in here. Y equals this whole integral c e negative integral of p of x dx dx over y1 of x dx square plus c1. All of this get multiplied by y1 of x. Now we distribute this out. We get y equals y1 of x c integral e negative integral of p of x dx dx over y1 of x square plus c1 y1 of x. Notice this is c y1 of x, that's 1 y of x. Then the second solution is going to be y2 of x, which is y1 of x, the integral e negative p of x dx over y1 square of x dx. So this is kind of like a shortcut. Instead of going through the whole process as we did within the first two examples today, you can go straight forward into this one and substitute the given y1 in, p of x, and do the integral. To apply this, let's look at an example. over the interval 0 to infinity means when x is bigger than 0. The equation x squared y double prime plus 2xy prime minus 2y equals 0 has y1 of x equals x as a solution. Find y sub 2 of x. Find y sub 2 of x using the boxed formula. Using the boxed formula. Let's go over it now. So to start with this one, y2 of x based on the formula, it's y1 of x, which is x, the integral x squared e negative 2 over x dx. Remember, you need to divide everything by x squared. So you can use p of x. Keep that x outside. You can't move it inside the integral. E negative 2 natural log of x squared dx. E, bring this up here, becomes x to the negative 2. So e to the natural log of x to the negative 2 over x squared dx. This is going to be x to the negative 2 over x squared dx, which can be rewritten as x to the negative 4 dx. And this would be negative 1/3 x to the negative 2 plus c. So this part here with no constant terms is our y2 of x. To try another one. So if y1 of x is e to the x, is a solution for the differential equation xy double prime minus x plus 1 y prime plus y equals 0. Find the second solution, y2 of x, using the formula above. Okay, so help me to find this out, to solve it. So we need y2. Before we do y2 or get y2, what do we need to do first?
Find the p of x.
So we find p of x first by dividing by everything by x. So p of x is what? Who's going to tell me what p of x is?
Negative x plus 1 over x.
Yeah, negative x plus 1 over x. Don't forget the negative sign. It's important to know the negative sign. Then y2 of x is y1 of x, which is ex. The integral y1 in the denominator square e negative the integral of p of x, so that becomes positive now, dx, right? The formula, this is the formula. So y2 of x equals e to the x integral e to the 2x here. How to integrate that one? We can split it up. 1 over x plus, 1 plus 1 over x dx dx e to the x. This one is e, the integral of 1 is x plus natural log of x. Then the smart way to finish this up on the top is to break it into two expressions. Then e to the x times e ln of x is x over e to the 2x. This can be rewritten as x e negative x dx. Now how do we integrate this one? Integration by parts, yes. Integration by parts. So u equals, so we're gonna use by parts to integrate this one. U would be what? So we use u to be x. Du is dx. dv is e negative x dx. So v is negative e negative x. So then y2 of x equals e of x outside. It's uv, so it's negative x e negative x, minus the integral of v du. y2 of x e to the x, negative x e to the negative x, minus e to the negative x, plus c, of course. And then what do we do? y2 of x is negative equals negative x e to the negative x times e to the x is e to the 0 minus e to the x times e to the negative x. Negative x minus 1. Yeah, you can put the plus c here. We have the plus c. Because we did the integral. So now, going back, what is y1? E to the x. So what is y2 then? Is this all y2? So this is the question I'm asking you. What is y2 of x in this case? You can, if you like, take a negative out. So imagine if we don't put the c at the end, right? If you don't put the c, what happens? If there's no c, this all this will be gone, right? Then we can say y2 of x is just simply x plus 1. You can drop that negative 1 out. If you look back in the formula, let me show you. in the formula here, there was no plus c at all. When you do it, we didn't do plus c. Remember, do you remember this one? We didn't do plus c. Even if you put plus c, you put it after you multiply. So this is what it is. So note, when you are working with integrals and then you have something, let's say like e3 natural log of x plus x dx, make sure to break it out. e3 natural log of x times e to the x dx. It makes things easier. Or maybe 2, let's make it 2 here. And then from there you can rewrite it, e natural log of x squared times e to the x dx, which is x squared e x dx. Then you can use integration by parts, I think twice. So when we use the shortcut, no need to use the plus c. No need for the plus c term when using the shortcut or the formula. Another note, when working a problem, p of x can equal to 0 in some cases. So it doesn't mean there's something wrong, but it can equal to 0.